deal. And, good deal. And thank you for taking time off your evening to speak to the team. We're going to let the folks a few minutes to log in. And let me start with try to share my screen so that I can show the agenda. Let's see. There you go. Always looking for the command. Now, where is that share screen button? Oh, share screen. Right big right there. I'm sorry. Okay, let me see if I take that. Okay. Can you see it okay?
Yes, it's up.
Oh, good. All right. And if I were to change that to presentation mode, hey, that works for me. I do have a question, Jasmine, for you. That the company used your co-founder previously. How do you pronounce it? Daedalus?
Good question. I pronounce it Daedalian.
Daedalian. Okay. Alrighty. Okay. I'll tell you what. Okay. All right. Yeah. Yeah. Sometimes some of the team member try to get off another meeting, so it will be a few minutes late in logging into this meeting. And that seems to be one of the challenges that we're facing with the electronic world, that, we used to have the courtesy of having a 10-minute break in between before the next meeting so we can move around to the next conference room. With electronic, everybody's scheduled all the way to the 59 minutes and 59 seconds. So it's one of the challenges we'll have to figure out a common practice so that we don't overlapping everybody's time.
Maybe we should keep those 10-minute breaks.
Yes, I think that actually is it's a good idea. That is a good idea. Make that a universal rule. How's that?
Agreed.
So how's going with your program? It's I know you guys are busy building and testing the scale prototype, but I'll let you talk about that during your presentation. I'm sure the folks are going to be anxious to see. I'll tell you what. Well, let's go ahead and start. Hey, Nicholas, are you there? No, Nicholas is not there. So I'm not sure how to start a recording on my side.
I think it's already recording.
It's already started? That's great. That's great. Yeah.
There's a recording right
Normally, Nicholas will start recording, so that's perfect. Oh, okay. And with that, I'll tell you what. Let's go ahead and get started. And as usual, a few of our team members may log in as they were able to. Welcome to our working group number 4 public service meeting. Now, this is a meeting that we invited all the working group members because I think this topic is and the unique capability and design of the airplane are valid for pretty much all the working groups' interest. Jasmine Kent is going to talk to us about the updating the two-wing aircraft concept for the eVTOL age. Jasmine is the CTO and a co-founder at Dufour Aerospace. which is a Swiss company. They're building this hybrid electric tailwing eVTOLs for critical transport missions. She is passionate about technology, aviation, and sustainability, and bring to Dufour a decade of experience leading software team, including at Google. Hey, Stephen. And Sega. He's also previously co-founder Swiss autonomy and situation awareness startup, Dadling. I hope I pronounced it close enough.
That's great.
There you go. And afterwards, we're going to spend a few minutes to talk about the possibility and what topic you want to work on the next white paper. So with that, welcome, Jasmine. I'm going to let you have the floor. I'm going to stop sharing, and if I can find the right button. Okay, there you go. And do I still have my control here?
You are still sharing. I could try to, I know I cannot share until you.
Yeah, so let me figure out how to do that. No, it's a little challenging when you cannot see the control button. Okay. All right, somebody is a Zoom expert, can give me a hand on where do I find the control to stop sharing my screen?
I'm afraid I'm far from a Zoom expert.
Aha, okay. Yeah, well, I know we have a few smart minds here that's logged in, so if you can hear me, see if I can find the control button that, for some reason, the control command line on my screen disappeared. So, I think I've just found it. That's the challenge of having more than one screen.
Well done.
Pause share. How's that? Stop share. There you go. It's yours.
Great. Let me try and share mine. It says I'm screen sharing, but I don't actually see my screen. Does that seem to be working?
I have not seen your screen yet.
I can see her screen.
I've got her screen.
Great.
Oh, okay. Huh.
Thank you.
All right.
Awesome. So I will get started. Yeah, thank you so much for the invitation, and thank you everyone for joining. I don't have a clear idea of the interests of this group, so I would like to encourage everyone to jump in with questions, or of course, you can also ask questions at the end if you prefer. But generally, I like to keep it a little bit interactive. So do feel free to interrupt me. So thank you for the introduction. I am Jasmine Kant. I'm the CTO and one of the co-founders of Dufour Aerospace. My background is software engineering, which I have done for most of my career. I was leading teams at Google, as you mentioned, and I've always been interested in aviation and aerospace. It runs in my family, and about 7 years ago, I had the opportunity to co-found this company, Daedalian, with a colleague of mine from Google, Luc van Dijk. and we were working on flight control systems and situational awareness systems, particularly using machine learning technology. They're doing amazing work in that. I'm no longer with the company, but I strongly encourage you to check out what they're up to. And through that work, I ended up meeting my co-founders at Dufour. So our CEO and my co-founder Thomas is a helicopter rescue pilot for Air Zermatt. He flies these beautiful machines on the left here. And I've never met anyone more passionate about saving lives or about flying helicopters. And together with our third co-founder, Dominic Steffen, they built this aircraft on the right, also around 7 years ago. It's called Aero 1. It's the world's first electric aerobatic plane. And through this aircraft, they learned a lot about electric propulsion technology, particularly for manned aircraft. The first and most obvious thing is the power of electric propulsion. It's kind of the Tesla effect. Thomas has a great story that his first flight in Aero 1 was actually unintentional. That's how powerful it is. Of course, despite all that power, it is a battery-powered electric vehicle. And it's great when the batteries are full, the voltage is high. But once you have been out for 30 minutes, 45 minutes, and the voltage is low, when you're coming in for landing again, you do not have that same power. So this showed two important lessons. The first of which is that efficiency is very important in an electric aircraft. And the second is that using batteries for energy storage alone is a very difficult proposition, especially with today's battery technology. Having discovered this, the potential of this technology though, Thomas and Dominic were discussing what the possibilities would be, what kind of aircraft could they build with it. And Thomas being a helicopter pilot, they started to look at VTOL possibilities. And they realized that in order to build a VTOL aircraft, they were going to need a more sophisticated control system. Aero 1, of course, being a conventional aircraft, had very classic flight controls with, cables and direct linkages. So they looked around and they came across Dedalian, my former company, and approached us, and that's how we met. We started discussing various concepts, the different possible ways of achieving vertical flight. I don't need to tell the Vertical Flight Society members about all the amazing ways you can achieve that. Multicopter, lift and push, tilt propeller, tilt rotor. But the one that we studied that struck us the most was the tilt wing. So this is the Canadair CL-84. It's a tilt wing aircraft. It was built in the 1960s. I suspect many of you are probably familiar with it, have seen it before. We really regard it as one of the inspirational aircraft concepts for what we're doing. And one of the great things about it and the program that was behind it is the amount of material that they published. So there are significant amounts of paperwork you can read up on that they generated in the process of studying this aircraft and the concept. They were doing simulations, they were doing tests. They built, I believe, 3 flying prototypes and had around 40 test pilots fly it. So they have a lot of flight test data. It's a treasure trove and really interesting to study. The main takeaways, I would say, of like why the tilt wing is the most, or a very favorable vertical takeoff and landing concept. Efficiency is the main one. So It has a fully washed wing. This means that it is highly efficient during transition flight. As soon as you start to tilt the wing, you are generating lift from the wing. You're not just relying on the props to generate lift anymore. Once you reach cruise, you have a very classic airplane configuration. There is very low parasitic drag. It flies very efficiently. At the same time, it has excellent handling qualities. So as I mentioned, there were like 40 different pilots flying this thing. They all gave it great reviews. They were testing it in storm force winds on aircraft carriers. It's an amazing thing. I was actually lucky enough to be able to travel, I think a year and a half ago or so to Canada, to the Aviation Museum in Ottawa, and see the remaining prototype of this aircraft. It's really an amazing thing to behold. Another cool fact and important fact about the tilt wing is the scalability of the concept. So this is a 6-ton aircraft, and this is a 20-ton aircraft. It's a very similar concept, the LTV XC142. It was being developed around the same time in the United States, and it demonstrated that the tilt wing can work effectively up to very large sizes.
When you were at the museum in Ottawa, did they show you the technical reports and literature in their library?
No, they did not.
Okay, the librarian is only there certain days of the week, and it pays to call ahead of time. And you know, like if you visit them again, you know, try to make sure that you visit when the librarian is around.
That is amazing to know. Thank you. I guess I can just call the museum, right? I don't need a specific contact.
Right. There's also a test pilot in Nova Scotia that has a treasure trove of Convair Canada inside corporate technical reports. He was one of the test pilot, Canadair test pilots. And when I asked him to look at those reports, probably about 10 years ago, 10 or 15 years ago, he was very reluctant. But, you know, time changes, and you know, he may be more he may be more
willing to share.
Yeah. He when I talked to him about, I think it was actually about 15 years ago, he still thought that Canadair, you know, may be able to do something, and so he was reluctant to show the inside reports to anybody outside of Canadair. But of course, nothing has ever been done in the intervening years, so he may be more willing to talk.
Wow. I guess it's unlikely at this point that they're gonna revive the CL-84, but that is super interesting. I can't actually see who it is that's speaking. What?
This is on the list there. I'm TH Fly, and my name is Todd Hodges. TOD.
Do you mind if I get in touch with you afterwards to learn more?
Yeah, go ahead. Yeah.
Cool. Thank you so much. That is super exciting. I would love to see what I can find out.
I also know where there are caches of reports on the XC142.
Really? Wow. I would love to speak to you afterwards. This could be really fascinating. the material that's publicly available is already super interesting. So I would love to see what they have in addition to that. Wow. Okay. Thank you so much. I will get in touch afterwards. So yeah, CL-84, XC-142, amazing aircraft. These are absolutely our inspiration for what we're doing. There's a quote that I've added here from a study in 1992 of various concepts, and they came to the conclusion that, again, that the tilt wing is a very favorable one. One criticism that's often raised against it, especially in this age of redundant distributed electric propulsion, is certification. People say like, oh, the tilting wing, isn't that a single point of failure? So I think it's important to point out that actually every airliner today is a tilt wing, or rather a tilt tail. They all have a trimmable horizontal stabilizer. It works in exactly the same way. So it's a multi-load path damage tolerant hinge with a jack screw actuator. It's possible to build these things in an extremely reliable way. They are fully certified today. Just a quick overview of our team. We have some really, really amazing talent on board. It's a pleasure to work with all of these people. I'm definitely now the dumbest one in the room most of the time, which is always an educational experience. I think it's important to point out that we have a lot of certification experience on the team in particular. So I think at last count, the team had worked on something like 80 different certified aircraft in total. I will show you a quick picture of this. This is Aero Mini. This is our subscale test platform. So we are flying with these every day. We are testing software, we are testing systems. It is a risk reduction strategy for our larger aircraft. And this is what we are primarily working on today. So this is Aero 2. It is an uncrewed aircraft. It's a tilt wing, obviously. It uses distributed electric propulsion, but it is also a hybrid. So it has an engine on board, a thermal engine, 2-stroke with a generator, and it is sized to provide enough power for the cruise phase, plus a little bit extra to recharge the batteries, so that you do not have that problem of coming in for a landing and having a low voltage in your battery system. This is one of the key advantages that we have today over the previous generation of tilt wings. So by using electric propulsion with a range extender, we can achieve a much more weight efficient propulsion system for an aircraft like this. When you look at the power installed in the CL-84 and the XC-142, for example, the power to weight ratio is just crazy. And that means you're losing a lot of potential payload there. And we have the ability to size everything much more precisely to the needs of the aircraft. We've built 3 generations of prototypes of this aircraft. We've done thousands of flights with it, with all of them through the full envelope. And we've been able to do all of this, I believe, quite efficiently with a team of 40 people, something that I'm quite proud of. In addition to the hybrid system, we've made a number of other improvements on the classic tilt wing concepts. It is, of course, fully redundant. We have designed it to avoid any single point of failure. This means that the running costs will be much lower, obviously. TBOs can be higher, maintenance cost is lower. It's clearly a lot more efficient to run than a helicopter, for example. the final improvement that we have over the classic tilt wings is digital control. It's a kind of an obvious one, but a massive portion of the weight of previous tilt wings was in fact the control system. With shafts, gearboxes, they had mechanical computers to do all the mixing. These things were really beasts. And of course that complexity came with a maintenance cost as well. We are working with a number of partners on this, probably the most important of which is our launch customer, Sprite. They are a subsidiary of Air Methods. And in November, they ordered 40 aircraft with an option for a further 100. The intention is to use it for critical cargo transport. That's what we're designing it for. In particular, they're in discussions with a number of major clinical laboratory service providers. At the moment, transporting samples for testing in clinical laboratories is a big bottleneck, especially in the US. So often samples are being transported by ground-based courier overnight. And that means you have a long lead time before you get results. That means that patients are having to stay overnight in hospital before they can get the results. That leads to more cost and poorer medical outcomes. With an aircraft like Aero 2, we can bring that lead time down to just hours. It has the potential to make a big difference. This is an overview of the clinical laboratory services use case. We can also do organ transplant, organs for transplant with this aircraft. Additional partners that we're working with and companies that have signed LOIs are here. There are a bunch that are not yet public, but it's really a great pleasure to have this network, and we learn a lot from our interaction with them. We are also seeing interest, I think I missed a slide that I wanted to insert here, but we're also seeing interest in other applications, particularly mapping. So there's a great potential to provide a mapping service that sits between smaller commercial drones and satellites. Today, that is mostly done with crewed aircraft, but with an aircraft like Aero 2, we can dramatically reduce the cost of image acquisition and potentially therefore enable much lower latency update rates for mapping service providers. Another very interesting use case that is emerging and we're seeing a lot of interest in is fire management across detection and monitoring through to coordination during fire response activities, and then fire suppression during the later stage of monitoring fire. There's also potential for reforestation applications. We've had some talks with companies that are doing seed distribution, tree planting applications. So the possibilities are extremely broad for this aircraft. Of course, it's still an uncrewed aircraft. It's got a payload of 40 kilograms, a range of 400 kilometers or so, potentially more with extended fuel tank. So that kind of limits the range of what's possible with it. However, as I mentioned before, the tilt wing concept is highly scalable. So I'll show you where we're going next. And that is this aircraft. This is Aero 3. We have designed but not yet built the first experimental prototype. This aircraft is designed for medical transport. So it is, in many ways, it's quite similar to Aero 2. It's a tilt wing. It uses distributed electric propulsion, but with a hybrid range extender. In this case, the range extender is actually a turbine, much as you'd find in a helicopter, rather than a two-stroke engine, but the principle is the same. One point that I forgot to mention before, by the way, because it is a hybrid and the batteries are the primary energy source and propulsion system, that means that your hybrid range extender is effectively an APU. So that reduces your cost, and especially your maintenance cost and inspection intervals, or increases your inspection intervals. Of course, so Aero 3
Okay.
is
Excuse me. When our team members are not speaking, would you please mute your computer or phone? Thank you. Sorry about the interruption, Jasmine. Please continue.
Of course. So we're building this aircraft for medical transport, and this is not an obvious choice of market. So let me explain why we're doing that. The first reason is that it is a very high value market. Medical transport is generally something that insurance companies will pay a lot for. It is a much higher value market than in general commercial transport, so just moving, paying passengers around. It's a market that we know very well. My co-founder Thomas is an active rescue pilot with Air Zermatt. He was also the CFO of the company for many years. It's a market he understands very well. Our chief commercial officer, Sascha Hardegger, was the former head of helicopter operations for Swiss Air Rescue, Rega. So we understand the market and we see the potential. It is a market with existing infrastructure. So we do not have to go out and build vertiports. Hospitals have helipads on the roof today. The infrastructure is there. The approach and departure paths are defined. The airspace integration is defined. All we have to do is build an aircraft that can operate as helicopters do today, and it can drop into this environment. The final reason, which I think is also quite an important one, is public acceptance. People understand the value of medical transport. If you are carrying billionaires from one place to another, people start to question the value of that, the noise that it emits, for example. But if you are carrying patients, the value is very clear to everyone. Everyone can picture themselves potentially being in that situation one day and understand why it's important. Of course, this aircraft is much more efficient than a helicopter for the reasons that I explained before. It is less expensive to operate per hour. It produces less noise. It is significantly faster than many helicopters. And that in turn gives cost savings because time is money. That means that we can compete very effectively with helicopters. Once this aircraft is certified and on the market, it should be a no-brainer for operators to convert their helicopter fleet to this aircraft. But it is actually so much more efficient than a helicopter that helicopters are not even our real competition. The real competition is ambulances, ground transport. It mostly comes down to speed. So in general, it should be possible to transfer a patient 6 to 7 times faster with an Aero 3 than it is possible today by ambulance. And that means that the medical team accompanying that patient needs to spend significantly less time in transit. And that is a huge cost saving. So overall, we expect to take a significant chunk of the ambulance market. There are various estimates out there for the size of this market globally, but it is somewhere around the $40 billion mark today, and it's growing extremely rapidly with aging populations and the centralization of medical services. We believe that up to about 40% of that market could be served by Aero 3. That is secondary transfers between hospitals and potentially some primary missions in rural areas. So it has a huge potential for medical transport. Of course, once you have an aircraft that can perform medical transport well, you have a broadly very capable aircraft in general. We will be initially certifying it for piloted operations. However, there is the potential to use it for automated operations, both in cargo and in firefighting applications. And in future, it may also make sense, market allowing, to use it for personal transport. The efficiency that comes with the aircraft concept means it should be possible to provide a very effective service for passenger transport in general. And I'm very proud to announce that we actually just closed last month our Series B financing with VistaJet. And this is a huge milestone for us. And yeah, we're looking forward to a great cooperation with them. That's about all I had planned within my slide deck. And as I mentioned, I'm not really sure where people's interests will lie. So I would like to say thank you very much for your attention so far and ask if you have any questions.
Wow, Jasmine, yeah, when I first listened to you talk, I thought, that makes a lot of sense. And listen to more detail here, and I say, wow, you really make a lot of sense.
Thank you.
Just my 2 cents. I'm a fan of CL-84 to start with. As a
Great.
matter of fact, somehow I have a copy of a CL-84 implementation plan. And so when I get a little time to scan it into the computer, I'll be more than happy to share with you. I think we all can learn a few things from excellent effort put into this program in the past. But I'm a strong believer in two wing for pretty much all the reasons that you already mentioned. Let me ask you this question. You mentioned that all the airplanes, including the 40-kilo payload and the air ambulance version, that will be highly redundant or avoid single point failure. Were you able to do that with any one of the, say, propulsor malfunction or disconnect, and the airplane still controllable, manageable?
That's the goal, yes, and we've been able to demonstrate that with our prototypes.
And when you're looking from the picture, when you tilt the wing horizontally or partial up tilt, can you do a short field takeoff if you want to preserve fuel or power energy on board to get a longer range or heavier payload takeoff?
No, yeah, that's a fantastic question, and I forgot to mention that, but yes, you're absolutely right. So if you have a runway available, you can save significant energy by doing a short takeoff or even a fully conventional takeoff and landing.
Great, great. And that's one of the beauty of I'm a strong believer in two-wing technology.
Yeah, so actually
it gives you that flexibility and options, yeah.
Yeah, it's great for a couple of reasons. One, you can integrate into existing CTOL traffic patterns, which is a big advantage if you're coming into an airfield.
Mm-hmm.
And another is reduced battery wear. So on a typical VTOL flight cycle, we expect to use about 10% of the battery. The rest is reserve. However, if you use a runway, even a fairly short one, you hardly have to touch the battery at all. And that means that you preserve your battery lifetime. Interesting fact, a lot of people assume that using batteries as an energy source on a vehicle is more environmentally friendly. But in fact, on an aircraft, if you're using batteries and you use pretty much a full cycle of the batteries per flight, because to do otherwise would be inefficient, you are going to burn through your battery's lifetime very quickly. And the public reports put out by I think Lilium and Archer both anticipate a battery lifetime of just a few months for these aircraft, after which you have to fully replace them. And creating these battery packs is highly energy intensive. So the environmental value of having a purely battery powered electric vehicle is questionable at this point.
I talked to Jack Reeder, who is a test pilot on the XC-142, as well as the CL-84 at NASA Langley Research Center. And he said that especially the XC-142, you could overload it enormously if you didn't have to hover. You know, if you did a short conventional takeoff, he said the payload would, you know, just be much larger.
Yeah,
And
we
so,
found that too. It's a great advantage.
yeah.
Wow, I'm a bit stunned, but like I'm really excited to learn more. I didn't really know what to expect from this talk, but yeah, I'm really looking forward to making these connections and potentially being able to learn more about both of these aircraft. So yeah, thank you.
Other questions, folks?
Yeah, I put a couple questions into the chat, but I'll just say them out loud. With your background in autonomy, I'm curious what kind of levels of autonomy are you pursuing for your Aero 2 and Aero 3 aircraft? Are you thinking for the Aero 2 that it's going to be operating mostly under positive pilot control, or will it be kind of like waypoint to waypoint, or will it be pretty much autonomous from takeoff to landing? And then the same for Aero 3. Are you envisioning the pilot is kind of a safety backup, or is it going to be a lot of augmentation of the pilot for control, or is it going to be pretty much stick and rudder for the pilot?
So starting with Aero 2, a significant design goal with this aircraft is cost efficiency. So we want to be able to operate at relatively low cost compared to crewed aircraft, for example. And that means that in the long term, we actually want to have a multiple aircraft to remote operator ratio, which rules out, you know, direct stick and rudder type operation. So we're looking at automated flight. In the initial versions of this aircraft, it will be very low levels of autonomy. The aircraft will be automated, so you do waypoint to waypoint, automated takeoff and landing. We have that already today. And over time, we will introduce greater levels of autonomy and decision-making capability into the aircraft. So initially, for example, you will have a detection system to detect other traffic and just report that to the remote operator. And then over time, we would incorporate that into detect and avoid and allow the aircraft to divert from its planned flight path and that kind of thing. However, it will be a very incremental approach. So initially, we'll be operating one-to-one aircraft to remote operator with constant supervision. And then, as I mentioned, over time, as the number of interventions required goes down due to the increased autonomy of the aircraft, we can start to introduce a one-to-many relationship between remote operator and aircraft. For Aero 3, we will be deriving the flight control system from Aero 2, increasing the levels of reliability and the DAL level of the software as needed. But all the same capabilities will be there, so it can be operated in the same way. However, we'll be initially certifying it for crewed operation, or at least that will be the primary certification path, at least under EASA eVTOL. This means we have a lot of flexibility in how we want to operate it. So it will depend a little bit on the jurisdiction and the needs of the operator.
I have another question. Oh, go ahead. TH, go ahead.
I put my email address in the chat.
Thank you. Now I need to find out how to find the chat. Okay, got it.
That's
Todd Hodges1@yahoo.com.
Perfect. Thank you. I'll send you an email. I feel slightly buzzy with excitement about this. This is like discovering a treasure trove.
okay. Well, I'll talk to you, Jasmine. I'll talk to you a little bit more offline because I have worked on a two-wing project back 15, 20 years ago. It's a ducted fan concept, but has all the similar consideration. Back then, of course, we didn't have the advantage of the distributed propulsion, electric propulsion system benefit, therefore still mechanical. But that's why I can relate to a lot of things you said, because everything struck me to, you found the sweet spot there, that the challengings and the drawback from the good old days of two-wing concept. I think we just now almost removed most of them. Render the two-wing order of magnitude more practical, more feasible, and probably safer than when folks tried 20, 30 years ago. So
exactly.
Perfect timing, I thought.
Yes, perfect timing.
Oh, I do have another question. Are you looking at your design, it seems like you can do, in addition, I think you mentioned that, but is there any consideration, because carrying people for medical transport does take a good deal of efforts and certification work and so on. Is there a possibility or consideration for using the platform, same design, for cargo transport on more remote location or for government use that may accelerate the time to delivery to market while paying for many of the core airframe development costs?
Yes, definitely. The airframe is quite versatile. So for the requirements for medical transport, you can then take that same aircraft and do very, very effective bulk cargo. As I mentioned, it shares the control system with Aero 2, so we can do it fully automated. And we are seeing interest in those markets.
I expect that too.
It would be an interesting way to have a parallel track that doesn't require the full SC-VTOL certification. Right.
Good deal. Any other questions, suggestions, idea, thoughts?
Having opened the chat, I see there's another question. What kinds of engineering tools have you used to design the aircraft? CFD, comprehensive analysis, custom in-house tools? What gaps in tools and kind of tool improvements would you like to see? So yes, we have used a lot of CFD and a lot of custom in-house tools. We have various kinds of simulation tools, from the CFD, FEM, through to a number of different in-house dynamic simulation tools. We do some kind of simplified longitudinal studies, and we do full 6-degree freedom dynamics for the control system, all of this stuff. There are, so many gaps and things that would be great to have. I think in a way it would be really nice to have a better, like, open source simulation development toolkit. So there are a number of kind of all-in-one simulation packages, but very often you have to then go all in with their system. You have to design everything the way they expect, and it kind of absorbs you into their model. And what would actually be great is to have a really nice kind of efficient set of C++ tools, for example, that allow you to build up simulations more quickly from pieces. That would be something I'd love to see. I haven't really seen anything like that out there so far.
Well, maybe we can all contribute to plug all the knowledge into the ChatGPT and let the ChatGPT develop that to the open source tool for us.
There we go. Yeah.
Hey, that's our new project, right?
Starting in the starting in the 1950s, all the way through about the mid 60s, there's an enormous amount of wind tunnel testing of tilt wing configurations and just generic tilt wing information generated in wind tunnel tests at NASA Langley. And you could use that to calibrate whatever analytical tools you have. You could calibrate them against these wind tunnel tests to make sure that you're getting the right answers.
That's a really good point. We haven't yet been able to do full-scale wind tunnel tests with our aircraft, so we don't have wind tunnel calibration data. For Aero 2, of course, we now have flight test data to calibrate against, but for Aero 3, we don't yet have a prototype, so we don't have that. So it would be very interesting. Is that data public? Can you?
Much of it is.
How would I find it?
You can go ahead and get a hold of me, toddhodges1@yahoo.com.
All right,
and
the email
I can tilt wings have been one of my favorite configurations. So I'm retired from NASA Langley Research Center. So I have a lot of stuff.
I used to work in a building overlooking there, seeing the enormous hangars.
Yeah, we're at NASA Ames.
Oh yeah, sorry, actually it was Ames, not Langley.
Yeah, I was at Langley.
Okay.
Yeah, and I think Wayne Johnson Ames has some of that data as well. I know we were doing some STTRs under the Small Business Innovative Research Program, and we were talking about that at a kickoff some time ago. Might even be flight data out there, which is good. But yeah, it's a really good approach, because yeah, it's great to have a open source sim, but the first thing is, how do you validate it? What data do you have via wind tunnel flight and such? So yeah, definitely worth pursuing those.
Yeah, to make this like acceptable to the industry, you'd need it to be backed by data and validation. And if you could make that fully traceable, you'd have a really powerful tool.
Chris, I think you just volunteered to make that happen. Hey, I mean, Chris is in the position to do that, right, Chris?
NTR.
Yeah, I can certainly help with the providing references to things.
Yeah, a joke aside, actually, that I think that's a super idea. I think the industry really can benefit from something like that, especially just TH just mentioned that with the wind tunnel data, with geometrical definition of the model tested, the specific test condition, power input, drain, thrust, whatever, that's, wind tunnel data is different than flight test data. Flight test data, in-flight thrust determination has always been a debated subject. I mean, I'm sure we can put 20 experts on in a room that they can disagree with how accurate, how well you can measure the thrust in flight. But wind tunnel, to me, is still a super valuable source of data that kind of fill in the gaps or balance out the source of the way that we can measure the certain type of parameters. So, and Chris, TH, I think we need to have a little mini project to brainstorm with Jasmine and team and other people interested. Maybe this can become a launch configuration. I mean, we want to make the tool globally applicable for all advanced configuration, but got to start somewhere, right? Since we have more fan tailwind fan here that I think you, Jasmine, I think you just found yourself a little team here.
I'm really excited to hear the enthusiasm and support for tilt wing configurations. I'm very often in like eVTOL conferences where people are mostly working on different configurations, and I feel like the outlier trying to tell everyone how great tilt wings are. So it's really refreshing to come here and have people saying like, yes, that makes sense.
Yeah, you're among friends here. Also, the use cases you mentioned, now that's exactly in line with pretty much a lot of things we were talking about. We've been working on in the past several years. So it's refreshing to see your thought process, your team, the direction you're going. Just encouraging. It's so. Any other thoughts, suggestions, questions for Jasmine? Yeah, there you go. Todd is a great source. Yeah, so yeah, we're going to definitely leverage Todd's knowledge and past linkage.
I will do so. I'm going to email him right away.
Good deal. Good deal. And please copy me. I'm a fan. I'm a big fan. So
Okay, will do.
Yeah, good deal. All right, I'll tell you what. It's been a wonderful presentation and dialogue. I think this is what the working group is about. The ideas, the progress, the direction, and encouraging efforts that's ongoing. So with that, I'm going to really want to thank Jasmine Kent again for bringing this wonderful topic and encouraging effort that's ongoing. So next time I'm going to travel in Europe, I'm going to make myself a little note to stop by Sweden.
You're very welcome.
To brainstorm with more folks that you guys were working on.
You'll find a bunch more tilt wing fans here. And yeah, you're very welcome to come visit. So
sounds good.
Thank you again for the invitation.
All right. And so with that, again, everybody, if you have additional thoughts, idea come out after this meeting, contact me. We have Jasmine's contact information. So that's the goal of the working group is to get the best idea on the table so that we can make a reality. And so thanks everyone, and thanks Jasmine. And with that, wonderful session. Thank you everyone. See you next time.
Okay,
Thanks so much.
see you later.
Ciao.
Thank you.